doing the Pearson Edexcel International Advanced A-Levels January 2023. This video is on question 5. So for those of you who just want to look at the answers for question 5 and then work it out for yourself, I'm just going to scroll through this previous working that I did. Question 5. Okay, that was question 5A. So you can just pause the video and take a look at it wherever you want. And then question 5B is over here. So if you can pause the video to take a look at that. Okay. But if you want some more explanations, then I'm going to do something a little longer. Question 5. Okay, so question 5 says that you have to prove that. Okay, so this is proving identities. It's got a little bit of a restriction on what x is not equal to, and x is an integer, excuse me, n. So let's take a look at this first. We're proving cot squared x minus tan squared x. So I usually set this out. This is my left-hand side, and we want it to look like the right-hand side. Okay. Sometimes you have to manipulate the right-hand side as well, but for now, we're just going to take a look at this left-hand side. So we have cot and tan. First step, make it into cos and sine. So cot is just cos over sine. And tan is sine over cos. So first step. Always the squares just stay there. Always looking at the answer that we're going for, and just you want to make it look like that. So you want cot cosec. And at the moment, we don't have cot cosec. Next thing that I like to do in this case is make an LCD. So I choose my LCD. I just times these two denominators together. Okay, so your LCD is sine squared x. Oh, that's a very funny looking sign, cos squared x. So that's my LCD. I have sine squared x cos squared x. So in order to get that LCD, you have to ask yourself, what do I have to do to cos squared x? Well, it has a sine squared x already in the denominator, so you have to times it by cos squared x in order to have the same denominator. And so we end up with a cos 4x. And same thing on the other side. We end up, don't forget, it's a negative in the middle, sine 4x. Okay, so now we've got this thing. And this is the difference between two squares. Difference between two squares you have to look for is a squared minus b squared equals a minus b, a plus b. So difference between two squares, that's what I'm talking about, but we're doing it with cosine, so we can immediately just spread that out. So we have cos 2x minus sine squared x. When I say 2x, I totally mean squared x. Cos squared x plus. Okay, so 1 plus 1 minus 2 brackets all over the same denominator. Oopsie. Okay, so looking at my working on the right here, just following on what I did before, obviously we know this is an identity that equals to 1. Okay, so that's sorted out already nicely for us. I just want to scroll down to keep an eye on my answer. So we know that equals to 1. What we're left with is a funny looking thing like this. Cos squared x minus sine squared x all over the denominator. Okay. Now, this top one is a version of, so this is a version of cos 2x straight away. So if you look at your double angle identities, this is one of them, okay, for cos 2x. So you don't have to even, I didn't write the identity in because it's a direct, one of the 3 options for cos 2x. So we can immediately write cos 2x there over the denominator obviously, yeah, I'm not going to go into all the double angle identities in this video. And then here I just took out the 2. So this 2 goes into the outside of the bracket. Okay. And the reason I do that is just to manipulate it. So we're always trying to make it look like the, we want it to be only 2 x's. We don't want any squares. We don't want any squares in the answer. We only want double angles in the answer. So we're nearly there. We're very close. We're very close. So then the next step, let's make this look a bit better. This is currently this. This is currently this. Okay. Now, I wanted this to be also a double angle identity. So I thought to myself, it looks a little bit like this. So it looks a little bit like this, because this would be equals 2 sine x cos x. Now, these are weird to do. Every time I do them, some people really can do it. Some of my students can, and some of my students struggle a little bit more. So we want it to look like this. Currently, what's missing is this 2. So if I had a 2 there, I would have to divide it by 2 again to make it look the same. Okay, so that's all that's gone on in this step. Okay, so if there was a 2 here, then you'd have to divide it, and then you haven't changed anything in it. So then this is exactly the same as this, and we can then we can exchange it for the sine 2x. So we end up with cos 2x over that whole thing switches out, the sine 2x. So, but that 2 is still there because we manipulated it to look like this. Okay. Now, I just wanted to clean this up a little bit. I start seeing now I've got my 2 x's, so I'm nearly there. I know that I'm nearly there. Go back and peek at my answer. I know I need cot and cosec. So I know I'm nearly there. Cot and cosec, it means that I'm going to have to do a little bit more to this to get cot and cosec. But anyway, that's just times it out. So I'm just timesing the 2 in. It goes to top and bottom. So cos 2x is sine 2x. Oh, if I were, so this is sine 2x, but there's just 2 of them. Okay. So this is just what I'm doing here. So we end up with sine, whoopsie, 2x times sine 2x over 2. So, oopsie, not 2. So this times the 2 to the power of 2 is 4. Now we are so close. The reason I did it this way is because I want to look at my options. Okay. Once we've got this, and now some of my students know this, that if you have the 4 over 1, then that 4 can actually directly go to there. But I don't want to teach it that way. So let's look at tip and times. Cos 2x over sine 2x times sine 2x. If you tip and times, is times 4 over 1, because it was divide. Okay, it was divide, so now you tip and times. So this becomes 4 cos 2x over sine 2x times sine 2x. And at this stage, we're here. I'm going to go look at, this is the answer that we're going for. We're going for cot and cosec. So obviously cosec is 1 over sine. So if I were to split this up in the direction that I want, maybe you can see it already. This is 4 cos 2x over sine 2x times by 1 over sine 2x. So as if you know your identities, 1 over sine 2x, just the inverse of cosec. So it's just cosec 2x. So we're already there. And this is just cot. So you don't have to write all the steps. Try to write as many as you can with proving, because you get marks. A lot of students try to just guess, so they're a bit more strict on proving. Okay. So for cot 2x and cosec 2x, yeah, we're there. That's it, done. That was number 8. Okay, B, now we've got that. So B says we want to solve for theta between minus pi over 2, which is, I guess, pi over 2, that's 90, and pi over 2. So between minus 90 and 90. When theta, so this is exactly the same as this, so just to note, is equal to this thing. Okay, so we can, if this is exactly the same as this, we can take, I wonder if I have a pen. Just want to doodle on this. Oh, good. So we can use this interchangeably with this. Okay, so this is a bad pen, so I don't use it. Anyway, let me clean this up a little bit for the video. Okay, let's take a look at what happens. So if I just go to my working over here. Okay. So what happens to we want the exact values. So we can say that if that second part is equal to, you see, here I put an X and a theta. This is the kind of mistake that all my students do it. I do it, everybody does it. So this should be a theta there. Where's my highlighter? Highlighter, please. Okay. So I just interchanged it for this. Then we have that next part. So straight away we have cot squared theta minus tan squared theta equal to this, 2 tan squared theta, and we want an actual value for theta. Okay. Actual value for theta will answer this question. So just don't forget the restrictions at the end. First thing I did, take tan over the other side. So 2 tan plus 1 tan is 3 tan squared theta. So we have a cot can be rewritten as 1 over tan because it's an inverse. Cot is 1 over tan, so cot squared theta is 1 over tan. Okay. I gave myself a common denominator. You can also just sort of, let's take a look. So I made the common denominator tan squared theta. So another way to look at it, then I did the way that I did it previously is just times this by tan squared theta over tan squared theta. So that's what I'm doing. If you times this by tan squared theta over tan squared theta, once the denominators are the same, so it looks like this. Once the denominators are the same, if it's an equation, you can drop them. Okay. 1 equals to 3 tan 4 theta. So now we have something that's starting to look like something I'm just going to reverse these for the teaching purposes. You don't have to do that. It's just for me to show from left to right. Divide both sides by 3. Okay, now just make sure that you notice that there's a 4 here. So that would be one mistake. And it is plus or minus the 4th root because it's an even number still. Oh, my pen. There we go. So tan, so minus 1. Oh, I didn't do. No. You have to get rid of the 4 first. Oopsie daisies. What am I doing? Okay. No, I was correct this time. Good. So first 4th root it. And there we go. Just sorry. My brain just went to sleep for a second there. This is tan theta 4. So just to give you an idea of what I had to 4th root both sides to get rid of the 4. Okay. Good. Here we are. Now we can tan to the minus 1 it. Theta. So this is what we end up with. And this, you can just stick into your calculator on what theta is. So I get these two values, I round them to 2 decimal places, and I get that theta on the positive side is 0.65, and on the negative side, I got negative 0.65. And this is correct according to the mark scheme. Both of those are correct, but I just checked it. So take a look at my checking system here. I made sure that it was within the restrictions by converting pi over 2 to radians. So negative 1.57 is just pi over 2 in radians. So I could see what I was doing. And these are both within those restrictions, and that's correct. Always check your restrictions and just make sure that they're within it. Okay, I think that was the end of the question, and I can't remember which question 5. Good, done.